frequency counter and buffer for radio. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. The internal oscillator of a superheterodyne radio is usually set to oscillate at a frequency corresponding to the tuned 1 plus the intermediate frequency. For example, if the radio is tuned to a station at 1000 kHz and the intermediate frequency is 455 kHz, the oscillator would be oscillating at 1455 kHz. It would be possible to intercept the signal from the internal oscillator and feed a frequency counter, subtracting the intermediate frequency and obtaining the value of the tuned station frequency. However, to provide a suitable signal without disturbing the function of the local oscillator, it is necessary to interpose a buffer with a relatively high input impedance and a low output impedance suitable for the frequency counter. This buffer should also be capable of dealing with an input signal that could range from only a few volts up to 100 volts peak to peak. The following was inspired by a similar project from Mr. Carlson, and if you are interested in this subject, you should definitely check this and other videos from Mr. Carlson on the same topic. What is represented here is a personal design for an RF buffer, which worked well on a few projects so far. The purpose of this particular buffer is to make sure that the input has a fairly high impedance, regardless of the input frequency, making sure that the FET transistor Q1 would not be destroyed by an excessively strong input signal. The rest of the circuit is designed and tested to avoid internal oscillations. Therefore, each stage is coupled by only a very low capacitance. The circuit could be powered using the tube filament voltage, provided that it is grounded and that it is available from between 4.2 to 12.6 volts AC. To protect against accidents, there is also a resettable fuse at the power input. The output of this buffer circuit is low impedance, but it is also very low in terms of voltage. Therefore, it requires a frequency counter that also contains a preamplifier. This buffer should be connected to the plate of the oscillator side of the converter mixer tube or to the cathode of the oscillator tube. This board could be hidden under the chassis close to the oscillator or at some distance if the input is collected using a shielded cable. The output has a very low voltage compared to the input. Therefore, the presence of this circuit under or above the chassis should not cause any trouble. The frequency counter could be built starting from a ready-made module. The PLJ6LED-A was used for this project. This particular module, ending with the letter A, is capable of operating between 0.1 and 65 MHz. What is very important about this module is the configuration that is obtained operating with two buttons on the rear. However, it is possible to connect in parallel two external buttons, normally open, that could be made accessible in a more comfortable way. This clip shows a model for a different frequency range, which is otherwise identical and has the same type of configuration procedure. The intermediate frequency is set to 455 kHz. The intermediate frequency value should be subtracted. This shows the configuration of the display brightness. Even though the frequency counter module claims to be very sensitive, its high impedance input would allow the collection of noise that would interfere with a correct frequency measurement. Therefore, it is necessary to interpose a preamplifier with a low impedance input. Here is the schematic diagram and the construction plan on a standard perforated board. However, in place of the resistors are two multichurn trimmers of 200 kilo-ohms each are used so that the resistor values could be adjusted for obtaining the best output signal. The following accelerated clips show the process of building and testing the preamplifier. The board is connected to a bench power supply, a signal generator, and to the oscilloscope. Then the trimmers are adjusted for obtaining the best amplification of the RF signal coming from the signal generator. Finally, the RF preamplifier is connected temporarily to the frequency counter module, and it is verified that the couple can work sufficiently well. These accelerated clips show the full construction process of the frequency counter, starting from the large rectangular hole on the front panel, using a hand nibbler first and a file later. Using these tools, especially the drill, one should be aware of the necessary measures to protect themselves, especially eyes and hands. two case panels get scratched in the process and need to be painted to cover these imperfections. For this project, a 9 volts switching power supply was used. This type of power supply adds noise to the AM reception. Therefore, it would be more appropriate using a traditional transformer with the other necessary components for stabilizing the output DC voltage. Two fuse holders are installed on the back panel to make sure that they would not turn while inserting and removing the fuses. Some super glue is used to keep them in their final position. Some super glue is used also to make sure that the power cord could not be pushed or pulled from the back panel. For personal safety choice, the metal case and the front panel are connected to the external ground. The frequency counter is tested, and here is a last view inside the case. In the previous section, there is no footage about the extension of the push buttons on the frequency module board. This clip comes from the building of a previous version of the same type of frequency counter using a plastic case instead. The frequency counter is tested using a signal generator to see what is the maximum sensitivity and the accuracy. Also, the configuration for the subtraction of the intermediate frequency is tested. Obviously, setting the intermediate frequency to 0, the unit would work as a cheap general-purpose frequency counter. This clip shows the typical usage of this frequency counter for measuring the cycles of the internal oscillator of a radio, subtracting the IF value, and obtaining the radio-tuned frequency.
Yeah, I think so. That's like what, post-20? Yeah, those are kids.